In question 1, I'll start with the left-hand side, which is 1 and 2 over 3 plus 2 and 3 over 4. I'll make the denominators the same, so I've got 1, 8 over 12 plus 2, 9 over 12. This gives me 3 and 17 over 12, or 4 and 5 over 12, which is equal to the right-hand side, hence proved. In question 2, the ratio of the girls to the boys to the total is equal to 3 to 1 to 4. In reality, I've got 60 children in total. That's 15 times more than 4. So I've got 45 to 15 girls and boys. Now 3/5 of the girls is 27 and 4/5 of the boys is equal to 12, and when I add this up I get 39. Now 39 out of 60 is equal to 13 over 20. For question 3, I will work with two right angle triangles. I will use the red one first to find the side QS, and then I'll use the blue one to find PQ. So using Pythagoras theorem, 14 squared is equal to QS squared plus 10 squared. So QS squared is equal to 14 squared minus 10 squared. This is equal to 96. So QS is equal to the square root of 96. I'm going to leave this like this. And then going to the blue triangle, this side here is square root of 96. So QP squared is equal to the square root of 96 squared plus 5 squared. So QP squared is equal to 121, which leaves QP the square root of 121, which is equal to 11 centimeters. For question 4, the range is equal to the maximum minus the minimum, which is 40 minus A, and this is equal to 14, which means A is equal to 26. Now to find B, I use the median, and since I have 4 values, I'll take the average of the middle two, so that's A plus B over 2. Now the median is 30, A is 26, so 26 plus B is 60, which means that B is equal to 34. To find the average speed, I will first convert the 8 minutes into hours, and this is 8 over 60. So speed equals to distance divided by time. So this is 30.5 divided by the time I found above, and this will give me 228.75 kilometers per hour. In question 6, I've got an isosceles triangle, which means that the angles at the base are equal. So 3x plus 10 is equal to x plus 52. So 2x is 42, which means x is equal to 21. So both angles at the base are PQ and RQP are equal to 73 if I use the x I found. Then to find y, I'm going to use the fact that the angles in a triangle add up to 180. So 180 minus the 273s, and this will give me 34, which is the value of y. In question 7, I've got the real and the model, and this is for both A and B. For the real height of tower A, I've got 187 meters. This is modeled using 90 centimeters. And for B, I've got 147 meters. This is modeled by X, which I don't know, I need to find. I'm gonna cross multiply. So X is 147 times 90 over 187. And this will give me an answer of 70.748 and so on, which rounds up to 71 to the nearest centimeter. In question 8, I can solve these equations either using elimination or substitution. I will proceed with elimination. I will multiply the first one by 2 and the second one by 1, so I'm keeping the second one the same. So I've got 8x plus 4y equals to 18, and x minus 4y is equal to 9. And I will add the two equations. I've got 9x, the 4y's cancel out, is equal to 27. So x is equal to 3. And if I substitute this in any equation, I'm going to substitute in the second one, I will get 3 minus 4y is equal to 9. So minus 6 is 4y. Y comes out to be minus 3 over 2. So 3 and minus 3 over 2 is the solution of these simultaneous equations. For part A, note that I can write 480 as 4.8 times 10 to the 2. And then I will add the powers of 10, and this will give me 4.8 times 10 to the power of 11. For part B, I will write 480 and then 10 as the product of prime numbers. So let's do 480 first. So let's divide by 2, 240, 220, 260, 230, 215, 3, 5, 5, 1. And then let's do 10. Divide by 2, 5, 5, 1. So 480 is equal 2 to the power of 5 times 3 to the power of 1 times 5 to the power of 1. Now 10 is equal 2 to the power of 1 times 5 to the power of 1. So my number n is 2 to the power of 5 times 3 to the 1 times 5 to the 1 times 2 to the 1 times 5 to the 1, all to the power of 9. Now the first one stays the same. The second part becomes 2 to the 9 times 5 to the 9, and I get this by multiplying the powers. And now if I add the powers of every prime number, I'm gonna get 2 to the power of 14 times 3 to the power of 1 times 5 to the power of 10. Now for part C, note the following. If I multiply two numbers and at least one of them is even, then the product will be an even number. The only case I'm going to get a product which is odd is if I multiply two odd numbers. So the largest factor of n that is an odd number is the product of 3 and the 5 to the 10, that is include all the odd prime factors, and this will give 29,296,875. For question 10, to find the shaded area, imagine that I have two semicircles, the red and the blue, and the shaded area is the area of the red minus the area of the blue. Now for the red one, the diameter is equal to 12, so the radius is equal to 6. For the blue one, the diameter is 12 minus 2 minus 2, so it's 8, which means that the radius is equal to 4. So area of the first one is a half pi r squared, so a half of pi 6 squared, and this will give me 18 pi. And then the second area is half of pi r squared again, but this time use a different r, it is 4. So it comes out to be 8 pi. So the total shaded area is area 1 minus area 2. That's 18 pi minus 8 pi, and this will give me 10 pi. For question 11, let's first remind ourselves about the formula for the mean. The mean is equal to the sum of the x, that is the observations, divided by n. And let's summarize all the information we're given on the table. Now, if I have a total of 12 boys and 8 girls, it means that I have a total of 20 children. Now, to find the total, the sum for the boys, this number here, I will rearrange the mean formula and get sigma x equals n times the mean, which means that the sum for the boys is 12 times 5.5, which is equal to 66. So the sum for all the number of children is 66 plus 18, which is 84, which means that the mean number of coins for the 20 children is 84 divided by 20, which will give me 4.2. For part A of this question, note that the sequence I have is not an arithmetic, so I can't use any of the formulae for the arithmetic sequences. Instead, I'm going to treat the numerator and denominator as separate sequences. Let's make a table to split the numerator and the denominator. Note that as n increases by 1, the numerator is the same. So for the nth term, the numerator will be just n. Now the denominator is a bit more tricky, but with some trial and error, you can see that the denominator is twice the value of n minus 1. So this is 2n minus 1, which means that the nth term can be given as n over 2n minus 1. For part B, let 2n plus 1 be any odd number. And I'm asked to show that the square of any odd number is divided by 4, then the remainder is 1. What this means is that I can write the final expression in the form 4 times something plus 1. So let's begin. 2n plus 1 squared. Let's expand as 4n squared plus 4n plus 1. Let's take out a common factor of 4 from the first two terms. So that's 4n squared plus n, close the bracket, plus 1. And that is in the required form. So I'm just going to conclude proved to show that I have finished. For part A, I will differentiate. To differentiate x cubed, just bring the power down. That's 3x, reduce the power by 1. So 3x squared minus, again, bring the power down, 2 times x to the power of 1 now, no need to write it. And then minus 8x to the 0, no need to write the x to the 0. And that's the answer for part A. For part B, I need to set the derivative from part A to 0 to find the turning points. So 3x squared minus 2x minus 8 is equal to 0. I will factorize 3x plus 4x minus 2 is equal to 0. So x is equal to minus 4 over 3, or x equals to 2. And these are the two x coordinates for the turning points. For part C, to show that the x-axis is a tangent to the curve, I need to show that in one of the turning points, the y-coordinate is 0. So let's try both to see which one gets a y of 0 at x equals minus 4 over 3. Y is equal to, let's show the substitution, squared minus 8 minus 4 over 3 plus 12. This is equal to 500 over 27. So that's not the one. Let's check x equals 2. We expect it to be 0 now, but let's do it. 2 to the power of 3 minus 2 squared minus 8 times 2 plus 12. And if you put this on the calculator, it comes out to be 0. Let's write a conclusion that at x equals 2, both y and dy dx equals to 0, hence proved. In question 14, I'm given the cumulative frequency diagram, and I need to find an estimate for the apartments with a value of 80,000 euros or less. So I'm going to go on the x-axis, find 80, find the corresponding y value, and that's the answer I need. And the reading comes out to be 97. In part B, I need to draw a cumulative frequency diagram for this information. Now, these will be my x coordinates, these will be my y coordinates. So let's put these points on and join them. Now I can join the points using a smooth curve or line segments. I'm going to draw line segments. This is easier for me. And that's how it looks like. For part C, I need to find an estimate for the increase in the median for the value of these apartments from 2015 to 2018. I've got 120 of them. If I divide by 2, that's 60. So I'm going to go on the graph, locate 60 on the y-axis, and find the corresponding y values. The corresponding values are 68 and 55. So 68 minus 55 is equal to 13,000 euros. Now the mock scheme accepts any answer between 13 up to 15. In part A of question 15, I get 3 to the power of 4 times x squared to the power of 4 times y to the power of 5 to the power of 4. 3 to the power of 4 is 81, and then I'm going to multiply the powers, so I get x to the power of 8, y to the power of 20. In part B, I will expand the two brackets first, although you can do any order you want. So 4n, and then I get n squared plus 2n minus 15. And if I expand this, I get 4n to the power of 3 plus 8n squared minus 60n. Part C is the difference of two squares, so I get 2c minus 3d times 2c plus 3d. And finally, in part D, I need to factorize both numerator and denominator, so I get x minus 4 times x minus 3 all over x 4 minus x. Now, if I cancel out the top bracket with the bottom, they are not identical. The signs are reversed, so I get 1 in the denominator and minus 1 in the numerator. So if I expand, I get now minus x plus 3 over x. And if I want, I can write this as 3 minus x over x, although this one is fully acceptable. For question 16, you can think of the problem as a tree diagram, although you don't have to draw the tree diagram. Note, I've only drawn the yellow or not yellow outcome since I'm not interested whether it's green or red. I'm only interested if it's yellow or not. And the probability they each take a yellow bit is probability yellow times probability yellow. So I need the product of these two probabilities. Since there's no replacement, the numbers on these branches are 2 over 12 and 1 over 11. So the required probability is probability yellow and yellow equals 2 over 12 times 1 over 11, comes out to be 1 over 66. For part B, if you decide to draw the tree diagram, now it becomes too big because there are 3 branches and then each one creates another 3, so it's going to look like this. So from the 9 branches at the end, I'm interested in the ones that do not give the same color. So the ones I am not interested are the ones that give the same color, and they are the following. So I can find the probability of these 3 combinations and then do 100% minus these 3. Let's put the numbers on the branches. So the probability of getting the same color is the following. Probability red, red plus probability green, green plus probability yellow, yellow. And if I substitute the numbers, I'm going to get the following. 7 over 12 times 6 over 11 for the red, plus 3 over 12 times 2 over 11 for the green, plus 2 over 12 times 1 over 11 for the yellow, and this will give me 25 over 66. So the probability of not getting the same color is equal to 1 minus the number I found above, and this will give me 41 over 66. For part A, the surface area of the cylinder is equal to pi r h for the curved surface plus pi r squared for the circle above plus pi r squared for the circle below. So I've got 2 pi r times h, which is 2r plus 2 pi r squared for the rest, equals to 4 pi r squared plus 2 pi r squared, which comes out to be 6 pi r squared. So k is equal to 6r squared. For part B, I will need the surface area and the volume for each of those shapes. The surface area of the cylinder is 6 pi r squared. We found this in part A. Now, the surface area of the sphere is 4 pi r squared. The volume of the sphere is 4/3 of pi r cubed, and the volume of the cylinder is pi r squared h. This is equal to pi r squared times 2r, which will give me 2 pi r cubed. Now, the ratio of the surface area of the cylinder to the sphere is 6 pi r squared to 4 pi r squared. I can divide by 2 pi r squared and get 3 over 2. Let's do the same for the volume. I've got 2 pi r cubed to 4/3 pi r cubed. let's multiply by 3 to get rid of the fraction. 6 pi r cubed, 2, 4 pi r cubed, and now I can divide by 2 pi r cubed, and I'll be left with 3 to 2. Note the two ratios are the same, so proved. In question 18, I'll start with the given expression, and I will multiply by the square root of 8 plus 2 over the square root of 8 plus 2. I'm trying to rationalize the denominator. So in the numerator, if I expand, square root of 8 times square root of 8 is going to give me 8 plus 2 root 8 over 8 plus 2 root 8 minus 2 root 8 minus 4. The 2 root 8 in the denominator cancels out. So I am left with 8 plus 2 root 8 over 4. This one is equal to, if I split this into two fractions, I'm going to get 2 plus a half of square root of 8. And note, square root of 8 is equal to square root of 4 times square root of 2, which is 2 square root of 2. So if I substitute this, I'm going to get 2 plus a half times 2 root 2. This cancels out, so I am left with 2 plus square root of 2, which is what I want and comes out to be 2. I'll start question 19 by joining B to C. Then the steps I will follow are the following. I'll find angle BED, this one here. This is 73 because there are alternate angles. Then I will find angle BCE, this angle here, and these two angles are the same because of the alternate segment theorem. Then I will find angle BCD, this angle here, because these two angles are opposite angles in a cyclic quadrilateral. And then to find the required angle, I will just subtract angle 2 from 3. So let's write this down. BED is equal to ABE, which is equal to 73 degrees, because alternate angles are equal. Step 2, BCE is equal to ABE, which is equal again to 73, but this angle because of the alternate segment theorem. Step 3, angle BCD is equal to 180 minus angle BED, which is 180 minus 73, which is 107. The reason is that opposite angles in a cyclic quadrilateral add up to 180 degrees. And finally, DCE is equal to 107 minus 73, which is equal to 34 degrees. I'll start question 20 by letting 2x be the side of the cube and also point N be the midpoint of BC. The angle I'm asked to find is the angle MAN. This is a right angle triangle, and let's extract it from the shape. Note that to find AN, I'll need to consider the base of the cube. Note that this, when seen from above, is a square with side 2x. Let's extract this from the shape as well. So I will work with the red square and try and find an using Pythagoras theorem. So an squared is equal to x squared plus 2x squared. That's x squared plus 4x squared, which is 5x squared. So an is the square root of 5x squared. I can simplify this as square root of 5 times square root of x squared, which is square root of 5 times x. So let's copy these on the blue triangle. So now I'm going to use the tan ratio to find angle A. Tan A is equal to opposite over adjacent. I'm going to cancel out the excess. So I'm going to have 2 over square root of 5. So A is inverse tan of this number. A comes out to be 41.8 to 1 decimal place. Question 21, I will use the cosine rule. This is given in the formula page. It looks like this. So let's rewrite this using the letters we have. So x squared is equal to y squared plus z squared minus 2yz cos x. So x squared is equal to y squared plus 5 squared minus 2y times 5 times cos of 60. Now I'm going to replace x with y minus 1. So y minus 1 squared equals to y squared plus 25 minus 10y times cos 60 comes out to be a half. So I have now y squared minus 2y plus 1 equals y squared plus 25 minus 5y. Now the y squared and the y squared cancels out. So if I take the 5y to the left, the 1 to the right, I'm left with 3y equals to 24. So y is equal to 8 and x equals to 8 minus 1, which is 7. So the perimeter equals x plus y plus 5. That's 7 plus 8 plus 5, which comes out to be 20. In question 22, I have a regular hexagon, and the nice thing with the hexagon is that I can divide it into 6 identical triangles, and each of those 6 lines, the blue lines, are equal in length. Now I'm given that AB is vector A, so does ED, and this is the same as F to the point of intersection. Let's call this point P, and PC is also A. Furthermore, I'm given that BC is equal to B, and this is the same as FE, which is the same as AP, which is the same as PD. So now I can work out DC, this one, as minus B plus A, because it's D to P plus P to C. So this is minus B plus A, which you can rewrite as A minus B. Now note that the triangle BCX, this triangle here, is an equilateral triangle, and it is exactly the same as any of the other 6 triangles. Note that these 2 are parallel and equal in length. This is an exterior angle of a regular hexagon at 60 degrees. This is 60, this is 60. So all 3 sides are equal in length. So this one is the same as this one. That's A. And also CX is equal to DC, which we just found to be A minus B. So EX is equal to ED plus DC plus CX. Let's see this on the diagram. To go from E to X, it's like going from E to D, from D to C, and then C to X. So this is equal to A plus A minus B plus A minus B. And if I simplify, I'm going to get 3A minus 2B. For part A of the last question, I'm going to use a trick. Let's see the relationship between 2 functions f and the inverse of f. Now, if f takes x and maps it onto y, then the inverse takes the y and maps it back into x. In our case, we don't have x and y. In our case, we have that p is mapped onto k using the inverse function. So p is entered as an input in the inverse. We get a k, which means if I go back to my original function and use k as the input, I'm going to get a p. So what this is saying is that this relationship can be written as p equals f of k. So let's use that blue relationship, p equals f of k. So square root of k squared plus k squared over k, and this is equal to square root of 2k squared over k. Let's continue on the right. If I split my square root as square root of 2 times square root of k squared over k, this will result in square root of 2 times k over k. Let's cancel out the k's. So I am left with square root of 2. Let's start part B by finding the composite function g f of x. Now this is equal to square root of x squared plus k squared over x squared. Let's split the numerator and denominator. So I get the square root of x squared plus k squared all squared over x squared. This square with the square root will cancel out. So I'll be left with x squared plus k squared over x squared. And then let's use the relationship I'm given. G f of a is equal to k, which means that a squared plus k squared over a squared. I'm just substituting a into the composite function, and this should be equal to k. Now I need to find a in terms of k, so this is just changing the subjects. So a squared plus k squared is equal to a squared k. K squared is equal to a squared k minus a squared. I've taken all the a's to the same sides. Now I'm gonna factorize on the right hand side. So a squared is equal to k squared over k minus 1. So a is equal to the square root of k squared over k minus 1. This is an acceptable answer. If you want, you can split the square roots separately in the numerator and the denominator, and you will get k over square root of k minus 1. Both of these answers are acceptable.